All right, welcome back. In this video, what we're going to be doing is extending what we talked about last time, where we had the basic project that we created using the internal MX perspective within CubeIDE. So we created that for our STM32 L432 board. What we want to do is we want to extend that to add in the ability to use printf to send that data, so when we print, we send that data out the serial port. So that's really our goal here, is to be able to do that. And one thing I want to do in this particular video is to plug a book that we found to be very helpful here, and I'll put that up here. This book, this Mastering STM32 by Carmine Novello, I think is great. I mean, it's a very, I would encourage you to pick this book up from LeanPub. The second version is great. He talks about FreeRTOS. It's just a good starting place. I would highly recommend it. He's got examples here, and this has become important to us here in just a little bit. He's got some examples here that he has placed. These are things that are referenced in the book, but these are on a GitHub repository, and so you can go and clone those. And we're going to need those because what we're going to be doing is we're going to be grabbing a file called Retarget, and that retarget.c, and this retarget.c file, what that is a set of stubs. In the libc that is used in the embedded space, the where printf, what the console is not defined, right? In an embedded system, it's not like when you're on Linux and the console is the screen, and that's or to the terminal, and that is obvious what the user wants. In the embedded space, the library is not sure where that's going, and so the part of newlib, which was done, I believe, by Red Hat and Cygnus. You can fact check me on that. I think Red Hat did that, but basically broke libc into a couple of parts. The part of, say, printf or scanf that does the processing of the string, down to characters. And then things like write and open, read, write, those sorts of things are left to the implementer to provide the stub that does the right thing, right? And so in our case, the right thing is to take those characters and shove them out on the serial port, right? And the particular serial port that we want is UART2. And so we want that to be sent out on that particular interface. So we need to provide those stubs. Right now, those stubs are basically blanks. They're placeholders. And so we're going to grab those files from the from this GitHub repository, so we can start with a retarget that's already done for us to save us from having to come up with that on our own. All right, so let's do the first part of this, and then I'll break this into a couple of videos, and we'll come back, and then we'll once we've got the files into our system, we've got them built, we'll come back and we'll try to figure out how we would look at that data. Where is the console, so to speak, when you're in CubeIDE. All right, so let's come back over here to our browser, and so you want to go to the Carmine Novello's Mastering STM32 link inside of GitHub. And so, you can grab this, in the normal way that you would grab GitHub things. I've got Git Bash installed on my Windows machine. If I were on a native Linux machine, I would be doing it from the command line. But so if I were to go over to let's go ahead and copy this. I'm going to copy this. And then I will go over to Git Bash here, and I'll bring that up on my side too. I'll do git clone, and then I will paste it in there. It looks like I've got some extra characters here, and let's see if that'll work. So it just pulls those files for me. Okay. And so now if I were to go in, and now I've got mastering STM32. You can do that in whatever way you use Git. Like I said, I tend to use this when I'm on Windows. I use Git Bash. Of course, like I said, when I'm on Linux, I do other things. And same thing with OS X. All right, so I've got these files. And so I'm going to switch over. Instead of doing that work, the next step in, I could copy this in my local file system through Git Bash. I'm going to show you with the file browser because I think it's a little more clear just in general. So I'm going to switch over here to the file browser, and you see my video production space here. But I'm going to go to this workspace. So this is my CubeMX workspace, and you'll see that is in your in Windows where they put that workspace is in your home directory. Under the STM32 CubeIDE folder, you'll get something called Workspace, and you don't have to put your files there. It's just you might want to put them there. I'm going to navigate over to Forge, where I've got my GitHub repositories, and I'm going to come into this mastering STM32, and I'm going to come down here to this L476RG. This is an example that, again, it's referenced in the book. But I'm going to go in there and I'm going to steal the retarget.c file that is used in this. And so if I come into System, Source, and then I look at retarget, and again, what these are the stubs, and I'm going to Control-C that. I'll grab that. Then I'm going to come back to my workspace, and I'll get in my L432 example, and I'll get into Core, Source, and that's where all my source files are, and I'm just going to copy that file in there. Now, the other thing that I need, those of you who are well familiar with C, I'm going to need the include file for those functions as well. And so I'm going to zip back over to Forge, and I am going to mastering STM32 and here, and I'll go into System, Include, and I'm going to grab retarget.h here. And I'll back up. I'll go to Workspace. I'll go into Web Example, Core, Include, and I'll just drop it in here. That way, when I'm in CubeIDE, it'll be able to find all these things, right? So when I build, it's going to, it'll find them. So it'll be put, it's going to build everything that it is in Core Source. Everything that's there will get built. So let's come back over to Cube here. All right, so I've got retarget here is sitting in my directory, and so let's do the sort of the first thing that would be done here is let's build it, right? Let's see if it'll build, and so I'm gonna hit the little hammer up here, or I might use Control B if it were just me doing this. So I'll hit the hammer, and it'll give me some errors. And what's it doing? It's telling me I've got some errors. So let's go to retarget and let's look. Okay, so when I look at retarget.c, it's got some weirdo paths in here which are relative to the project that I pulled it out of. So I've got to fix those. So let me patch those up. And so I'm going to come in here and I'm going to slim this down to just retarget.h. Now, that include directory where I drop retarget.h is in the include path for the compiler, and so it'll automatically look there. It'll find it, so I don't have to tell it where it's at here. So I'm going to save that, and let's build again. Okay, so now I've got this file here, and it is complaining here because it doesn't know about things that are actually in a normal libc include called stdio. And so the fact that that's not included, I'm getting all kinds of errors based on undefined and implicit declarations of functions. So let's go in and add the header for stdio. All right, so I've added that. So let's build again. All right, okay. We've got a new set of errors here, and you can see what's going on in here. Let me make this a little bigger so you can see it. So it built. And so this line here tells us, oh, retarget.c, it actually compiled. It did its thing. Okay, but when it came down here, it was trying to link it to make this particular file, right? And linkage is this idea that it takes all these object files and it tries to assemble them into one binary. But what it's complaining about here is it's saying, hey, you defined these functions like close and fstat and IC. You define those again in your retarget.c file, and we already had those defined. And so it's complaining you can't have two definitions in a C file of the exact same program, right? So, or the exact same function, sorry, the exact same function. You can't have two declarations of the same function. The compiler doesn't know how to choose, or the linker doesn't know how to choose. And so let's go in and fix that. And we're going to fix that with what's known as a weak declaration. And you'll see this here. If we go into syscalls.c, that's where this stuff is defined. We'll see that we've got these functions here, these underscore close, underscore fstat, underscore is a tty. And so these functions, that's fine. They're there. These are the stubs that are part of newlib, right? This is what are referenced by things like printf. It will call these functions once it's got a character stream that it wants to send out, or a buffer of characters. It will call things like write to send those to the particular device. And so we have redefined these in retarget.c. So let's go in, and what we're going to make these functions is we're going to make them weakly defined. And that's an attribute you can add to a function. And what that says is, hey, if you can't find another definition of a function, then use this one. But if you can, override it. I want you to use the other one. So in this case, that's really what we want. We want it to use the one from retarget.c where it can. And so I'm going to go ahead and here and I'm going to grab this attribute, which is being applied to read, and I'm going to copy it, and I'm going to copy it down to these functions that are causing us problems. You can see the little X there. And so I'm going to make all of these weakly defined so that I can grab the version that I was using in retarget.c. And so it looks like I've got no more errors. So let's go and save it here and let's build. Okay, and now we're built, right? And so now we've got a version that has retarget.c in it. And so so we've got, we really haven't changed the code, right? Because we haven't done anything in main.c yet that would lead us to even use retarget.c. So let's, we're going to come back in our next video and we'll add in how you actually turn on or initialize retarget, and then we'll look at how once we create, say we print something, where does that go? How do we grab that inside of CubeIDE? All right, that's it for this one.